Hello, everyone. Welcome to OpenShift Commons virtual meeting. So I am Valentina Rodriguez. I'm a Principal Technical Marketing Manager at Red Hat. I work with OpenShift, and it's my pleasure to really be here and be part of this amazing community. So this is really where customers, partners, and users, of course, just contributors join here weekly. And here with me, I have my friend Ricardo, who will be talking about Kubeflow and the AI lifecycle. So, Ricardo, yeah, the floor is yours.
Thanks, Valentina. Um, Welcome everyone to the OpenShift Commons. Today, I'll be talking a little bit about our efforts under Red Hat on the AI/ML space, including our contributions with the Kubeflow project. So, first of all, let me introduce myself. I am a senior software engineer at Red Hat. I'm working on some key projects in the past. I worked with the one project called the Red Analytics.io, which was one of our um, key contributions to the Spark community to bring Kubernetes workloads with Spark. And then I transitioned to the Open Data Hub community, which is a midstream project that gather contributions from multiple AI/ML projects. And one of the main projects that we contribute is the Kubeflow project. Um, I've been a speaker of many international conferences, including KubeCon Europe, the DevConf, and some of them. I'm based in São Paulo, Brazil, by the way, so it's great to be here. I'm a tracker. For those who don't know what does that mean, I'm a Star Trek fan. I love and I watch it pretty much um, all of the Star Trek series. So
That's
um, let's let's talk about the agenda. Um, so I'll be talking a little bit about the AI life cycle and about what MLOps is. Uh, then I'm gonna introduce the Kubeflow project. I'd like to highlight some of the Red Hat contributions under the Kubeflow project. Some of them are very impactful, and we believe that it makes the Kubeflow project even stronger with our contributions. And then I would like to focus on a specific component on the MLOps core, which is the pipelines. And this is the component I've been developing so far. So AIML to uh, operationalizing AIML workloads is not trivial. And the reason is because you have multiple phases, just like you have in a software engineering, and you have multiple personas involved, right? Um, it operationalizing AI/ML models is not the same thing as doing um, with software, because some of things differs from each other. Because one, you need two things here: you need code and you need data. And well, in the data science space, people say that all the effort to handle the data and prepare the data for training AI/ML models is pretty much 80% of all the effort. And this is still a thing. And even though we have all of this effort to have good quality data to train your model, you still might need more data to train your model. So um, there's pretty much more things here, but data is, of course, one of the big and most important parts to train AI/ML models. Training a model also needs um, some cycles to train the model, because you need to tune the hyperparameters of that model, and then you need to repeat some training tasks a lot of times. So this is one of the biggest challenges here. I got a research from the Gartner that asks the companies what is the average timeline to operationalize a model in their environments. And as you can see, 50% says that they spent 7 to 12 months to have their models from experimentation to production. So this is a huge timeline, given that time to market is requires a lot less than this timeline. So what is the idea to reduce this time to market to operationalizing AI ML models? So that's one of the biggest proposal for the Kubeflow, which brings the essence of the MLOps, which is pretty much what DevOps is, but with the difference that you use some given steps to train your model in an automated way, just like we do for DevOps. But some of the steps are different. So what the Kubeflow project is um, the vision of the Kubeflow project is to bring it all of the components and having them working tightly together to create an end-to-end MLOps flow for your environments. It runs on top of Kubernetes with um, some core components here, like Istio to have some management of the networking, tags for login, and some other components that needs in the platform level for Kubeflow. It runs on top of any cloud, public, local, self-hosted, or public cloud, and it can use any of the accelerators. So you could embed GPUs on your Kubeflow components to use so you can train your models using more robust infrastructure. So the MLOps end-to-end workflow proposed by the Kubeflow project is pretty much that flow that starts from the data preparation using a component called the Spark operator. Then you go with the model development, or we can also call it the experimentation using the notebooks project. Then you go with the cat tip, that is an AutoML task, so you can do hyperparameter tuning and model optimization. Then you use the training operator to do the training, or in the context of the generative AI, you could also do the fine tuning. Then you go over the K-serve, and you finally have your model ready to be used by consumed by your application. So use the model serving, the K-serve for model serving. So it's pretty much expose a model in a REST or the gRPC endpoints. You have the pipeline to automate off this process, so it can be repeatable and it um, can be well reproducible. Okay, so not only you can do the same task a lot more times, you can do this, you can have the same results every time with the pipelines. There's also the model registry. So in order to manage multiple models, multiple data sets, and you need to catalog them in a way that you can reuse a data set to train another model, there's the model registry. And there's also the registry for the data. In this case, that is the FIST, that does both online feature and offline feature store. So with both data producers, you can get feature generation and extraction and store all of them in the FIST project. Um, so Red Hat is one of the biggest companies that contributes with open source, and it's the same for the AI ML space. So our strategy with contributing with AI ML space is to get a lot of upstream projects. In this case, talking about Kubeflow, but there are others like Jupyter, Trusty AI, TensorFlow, PyTorch, Ray, Codeflare. Then you get all of these projects and we bundle on the midstream project called the Open Data Hub. And with that Open Data Hub project, we use the code base to create our own product called the Red Hat OpenShift AI. Some of the contributions we made for the Kubeflow project, I believe the biggest one would be our participation on the releasing the Kubeflow 1.9, where I was there as the release manager for the Kubeflow 1.9 release. We added a lot of features in there, like for example the model registry components, some improvements for the Kubeflow pipelines, like upgrading to Argo 3.4, and many other contributions we made. Not only this, we are now about to begin the release cycle for Kubeflow 1.10. We still have a lot of contributions to do with the Kubeflow project, and also we're waiting to um, embed even more components to help with um, enrich your MLOps end-to-end workflow. So I believe with the Kubeflow 1.9 release, this was one of the biggest contributions we made in the past 6 months. Um, One other key contribution we made, we established a Kubeflow stream committee for the project, in which one of the KSC members is a Red Hatter, along with Google and Apple and Nutanix. We're also working to help Kubeflow project to reach CNCF graduation, especially on the security aspects, because uh, they need to focus on the security today. So we're working on helping it on that. And some other work in progress or projects that we expanded to the Kubeflow project is the conformance testing, uh, in which conformance testing is about having other distributions officially tested uh, as Kubeflow distributions. So there are um, a list of 8 to 9, I believe, distributions today, but we don't know yet what a Kubeflow distribution is for the community. So we're trying to revive this concept of the Kubeflow distribution and create a conformance testing so others can create their own Kubeflow distributions. What I would say is another good and impactful contribution we made for Kubeflow. We wrote a proposal for the Google Summer of Code, and we got something like 100 students applying to the Kubeflow project over the 10 projects we have available. And we got not only the 10 projects approved in the Google Summer of Code, but also we got at least one of two contributors or two students for each of these projects. So it's a huge achievement for the Kubeflow project, and we help it on getting this achievement done. Um, some other things we're doing along with the Kubeflow project and the Open Data Hub projects, we are bringing all of the components, Kubeflow components, to be part of the Open Data Hub midstream project, and it will be in the future part of the OpenShift AI products. Kubeflow training operator is one of the work in progress. Um, Cative is one of them. Model registry already was already born under Kubeflow as a Red Hat project. So model registry is already part of OpenShift AI, just like Kserve, um, pipelines, notebooks. Um, there's also Feast that we would like to revive under both communities, the Open Data Hub and the Kubeflow. And we're also proposing some improvements in the UI and the UX for Kubeflow, especially using newer front-end libraries that helps them to deliver better and richer UI UI front end. With all of these contributions we made in the past 9 months, I would say we are now considered number one uh, contributors of the Kubeflow project. So we achieved it recently, and that's a great achievement, I would say, because we started with a few contributors, and then we reached it with a number of more than 12 contributors today from Red Hat. And we made a lot of contributions, especially the introduction of the mother registry in the community. And we're also working on other contributions. So I'm very happy to um, announce that we are leading contributions under the Kipler community. So I I talk a lot about the MLOps process very briefly, and also I brought the Kiplo project. But I'd like to also mention what is the OpenShift AI that is developed with uh, merge of all of the other open source AI ML projects. So OpenShift AI is the main vision is an integrated AI platform. So it's where you can do MLOps end to end with a single dashboard by creating your models using the model development. Uh, there's also another um, another team under Red Hat that is working on creating models like the Granite family and the Struct Lab to bring some special capabilities to train those models. We are also planning to support all of them. Um, and also supporting traditional AI/ML with with their libraries, frameworks, and runtimes. We're also supporting model serving and monitoring, so you can deploy our models using a few clicks in the dashboard, and you can also monitor their performance. I'm talking about performance, you can also bring um, some key capabilities, like, for example, if the model is not drifting, which is a very important and risky part of the AI of the MLOps life cycle when you are putting your model in production. So it's also possible to do some monitoring them. It's also possible to manage your life cycle end to end in the OpenShift AI dashboard, and also you can make use of all of the um, accelerators, all of the workloads that needs to train your predictive or generative AI models. You can also have a collaborative environment where you can share your resources, projects, or models across your environments. There's a concept of a data science project inside OpenShift AI. So you can create your own project and you can share with other teams or other users, and then they can use under this project all of the development of your models. So with everything inside, pipelines, experimentation, resources, etc. This is available as a managed cloud service, or you can create on demand in other public clouds like AWS, Azure, Google Cloud. So I'd like to emphasize one of the key components inside the OpenShift AI and the Kubeflow. which is the pipelines feature. Under the OpenShift AI product, we call it the data science pipelines feature, which is pretty much where you automate all of the steps to train your model. Of course, the best way to go with from experimentation to production is having data scientists to experiment some m- model some algorithms, some models that could be um, meaningful for the the business you're trying to solve here, for the problem you're trying to solve. So with that, you need some steps here, and it pretty much involves other personas in the MLOps flow, like for example, the data engineer to gather and process data, and then you get the data scientist to use this pre-processed data and train the model, or downloading an existing model if there's already one trained for with the same data. Then you compare the results, see if they're performing better, and then if you think that this model is performing reasonably well for your needs, you can push this model to production or to other environments if it looks good for you. Like so, this is a continuously and it's repeatable, reproducible process that you need to do, because uh, maybe um, you can get a roadblock when gathering and processing data. Like for example, you're not getting uh, enough data to train your model, so you need to find ways to gather more data. And sometimes the model that you are gathering does not um, bring your model to good, accurate responses. So you need to check if gathering data is the problem or processing the data. So uh, doing all of these steps manually takes a lot of time and involves a lot of people, right? So that's the biggest reason why we have pipelines under the Kubeflow and the OpenShift AI products, because we need to automate those steps to not involve too much people, and you can schedule some executions, like for example, every every day you collect more data, and then when you pre-process the data, you can trigger another pipeline that can train the model, and so on. So this is one of the biggest reason we use pipelines under the MLOps flow. Um, One of the things that we added into OpenShift AI is that we have a graphical front end where you can build those pipelines by just dragging and drop um, assets, like for example, notebooks or Python scripts, Python or R scripts, and then you can create all of the pipeline flow here. That makes things easier to even experiment some pipelines runs you would like to bring to operationalize your models. Um, Under this task, you can orchestrate data science tasks. You can chain together other pipelines. Like for example, you want to make gather and process data one specific pipeline, train the model another one, and comparing could be another step. So you can make those pipelines separated and then chainable together in order to execute in a single run. Um, Not to mention again, data science pipelines is just a project based on the upstream project called the Kubeflow pipelines, and it's also a key component under the Kubeflow project. So again, uh, there's much more about the experimentation using the notebook. The notebook. So you need to do all of those experimentations by writing some code. Sometimes you need a few data just to understand if the hyperparameters are pretty good, then you need to do some fine tuning. You need to maybe gather more data, maybe process the data in a different way, and all of these tasks takes a lot of time. So um, one of the tasks that uh, we're talking about being so complex that needs a lot of time and people effort to make them successful are the data analysis, explaining the data, because you need to create some chunks of data to train your models, scoring the model training, and then evaluate them. Um, some of these steps you could like skip because they are pretty much redundant. Like for example, you don't need to do the data analysis every time you are training your model. So you can do this differently or separately main uh, from the main MLOps flow. And if you do this separately and doing fewer times, you can save computing and time resources here. And you can, for example, in another model training task, you could use, for example, specific resources like accelerators, aka GPUs, for running this task. Uh, it saves time with training this model, um, and it's way better to train models on GPUs than on CPUs. So there are some tasks that you need to work differently because you have fewer resources, and then you have more specific training tasks that you need to run under your models. So when you're just experimenting, you don't need the GPUs in there, but when you need to do fine tuning those models, you pretty much need uh, more robust resources like GPUs. So you can separate those tasks and make them reproducible and repeatable. So one of the proposals we have for using ML, having an ML workflow with OpenShift AI is using from data exploration and the pipeline development you can do in the same task, if I can say that. You can start working with Jupyter by creating your experimentation notebooks, running some code to train the model with uh, fewer resources, fewer data. But you know that when you scale up the data and resources, you know that this will get this almost the same result here. Um, with those notebooks where you're using for experimentation, you can also use them to create your pipelines using the Elara component, where you can just drag and drop those notebooks, those Python scripts that you're using to do the experimentation, and chain them in order to create this pipeline. At this point, Jupyter and Elara uh, run in the same dashboard, the same IDE, but Elara pipelines is mostly useful when you are experimenting not only the model training tasks, but also how to make them automated, right? Um, with that, you have uh, a good model, a good training code to train your model, and you have this automated task with all of these steps, like with the data ingestion, with the training, with the scoring pipeline. Then you go with running into production. So you use data science pipelines to bring the same steps in there, but uh, well, you can reuse the notebooks, but you can also create another one by just reusing the code you have. We believe that the most accurate and most um, scalable way to do this is by writing the whole pipeline in a single Python code and then compile it. and then schedule under the data science pipelines. In this part, we are now under the experiments tracking and the pipeline scheduling. So when you're running your experiments, um, you are producing artifacts. Um, you are running another experiments, and then you can track those data, those metrics, the best name for it. You can compare those metrics under the experiments, and also store those artifacts in order that you can reuse them in other pipeline runs. Sometimes you need to use a lot more resources that you could do. So you need something that you could um, schedule those dedicated resources to train your models. So you can use the Ray project. So you can create a way to um, schedule those resources like GPU, CPU, memory, and then uh, Ray um, use will create will reserve the resources for you, and then you can run your training task, and then you can just tear down the resources so it's available for other training tasks. All of this from storing in the model store all of the model versions, so you can versioning those models together. Um, at least you can use the model serving components to serve your model through gRPC, through REST. And when you're going to model monitoring, you're using Trusty AI to get any drifts in your model when your enterprise applications are consuming your model. Um, so this is pretty much all of the MLOps flow. We believe it could be done with OpenShift AI. Um, we could also include other components here, but I believe this is one of the basic pipelines we believe MLOps could be done with OpenShift AI. Um, some less things here. How to contribute with the Kubeflow project and with Open Data Hub. You could attend some of the conferences we are. We're always in the KubeCon editions. We also host the Commons Gathering in many locations. We also have the Summit Connect. For the Kubeflow contribution guide, for the Kubeflow project itself, I'll recommend take a look at the contribution guide, join the meetings and Slack channels. Um, don't forget that we are under the OpenDataHub.io. Uh, we also have a Slack channel, so join the Slack channel as well. Ask us some questions. But we're also in the Kubeflow Slack, and it's very easy to find us in the Kubeflow Slack as well. I guess that's it. Um, um, I believe this is pretty much what I have for today. So
Thank
I'm open.
you.
Any questions?
Yeah, no, thank you. This was great. Thank you so much. It was, yeah, so much information, but it was great. So we talk about the contributions to the community. We talk about the presence in the events, and you also give us a great overview of OpenShift AI, but also from the upstream process and talking about Qflow and how those models works. So I think the three things that stuck with me were like well the all those upstream projects that are part of OpenShift AI and how that is evolving through Red Hat contributions through the whole ecosystem. The other thing is that you were talking in OpenShift AI, you can run any model, and then how GPU is important to train the model, but also easily to really access through just the OpenShift as a whole, an application platform that provides that. I don't know if there are other takeaways that you want to highlight.
Yeah, I believe this is. I think it's summarized well. All of the highlights of the presentation itself. Um, I would like to say that also we have a lot of um, information to present, not only in those slide decks, but also I'd like to show some ways where you could experiment with OpenShift AI. So if I have some time here, I'd like to run
Yeah,
through
that would be great.
a quick demo
So,
here.
yeah, go for it.
Awesome. So let me share another tab I have here. This is our Red Hat developer website where we have um, a portal for every developer to um, gather more information about our projects. And it's free to register. And we have a special section here called the Developer Sandbox. And if you go to the Developer Sandbox, you can get access to an OpenShift cluster for 30 days, uh, all of them for free. And one of the services we put under the developer sandbox is the OpenShift AI. It's just taking a while here. Righty, almost there. Okay, so as you can see, there's this section where you can launch an OpenShift AI instance under your developer sandbox. When you hit launch, you will be redirected to the OpenShift AI login page using the dev sandbox credentials. And after some time, it's taking a while, sorry. Um, let's go. All right, it's loading. Awesome. So there you go. This is OpenShift AI
Wow.
dashboard uh, running on the developer sandbox. So it's free for you to try out some of the features we have in here. So there's this concept we call the data science project. So when you are running on the developer sandbox, you already have one created for you. When you go with the data science project, you have all of the features I was talking about, the workbenches, where you got the notebooks, you can create the pipelines, you can deploy your models, you can have some data connections to bring your data up from an external source, and also sharing those this data science project to other users and groups. So it's pretty easy um, to access OpenShift AI here. And going back to the Red Hat developers portal, uh, going to the Learn and AI/ML section, there are some learning resources to run some of those training jobs using the OpenShift AI. So there's a lot of good examples here. Those are all learning paths, but uh, all of them is um, pretty much using OpenShift AI. So there's this one to automate ML pipelines with OpenShift AI. So I highly recommend that. And yep, I think that's it.
No, this is great. Thank you. Because there are so much about AI nowadays, right? We hear AI in everything, right? So even as developers or platform engineers or anyone who are really interested on learning more about it or how to start, like I want to start because everyone's talking about it, and I want to gain more skills on it. And this is like an easy way that I just can go there and experiment for free. So, and also the learning pass, I think is a really nice way for like try and learn new skills. So thank you for showing us that. Um, Dwayne, do you have any questions?
Um, I,
Yes.
it was an amazing presentation. Thank you so much. Do you see in the Kubeflow pipelines any differences if you were going to try to apply on the edge where you may have less resources, would it be the same series of processes for the edge?
Yeah, that's a very good question. And this is one of the biggest challenges we're bringing on using OpenShift AI on the edge. Uh, well, sometimes um, we think that uh, when talking about edge architecture, um, we're also working on having those pipelines to work on fewer resources, but also there are other ways we believe that could be done, like separating those components that run in different steps and having edge to have model serving at most. Um, but yeah, there's still some work on edge architectures for OpenShift AI to have them running well under fewer resources. At some points, I believe model serving is doing a great job. Pipelines is going to that direction as well. But yeah, there are a lot of work to be done to have OpenShift AI running on edge environments.
All right, thank you. I'm gonna try to go and check out all the great information that you sent. That was amazing.
Awesome.
Thank you, Ricardo, and thank you. Yeah, thanks everyone for listening. I know I highly recommend you to, just connect with the community. It's a very welcoming community, open to everyone. So I started contributing and just joining the meetings. It's a great way to start. Ricardo, you have been amazing as well, providing information for me to get started and be involved with the project. So I appreciate it. So thank you so much, Ricardo. It has been great. And thank you so much all for listening. I will see you next week. Thank you.
Thank you.